Hello, good morning, everybody. This is Michael from coachapilot.com. HTTPS coachapilot.com. I am an ATPL instructor, and I've helped hundreds of students and pilots to prepare their ATPL exam. And today I wanted to talk about meteorology. So I have found a question that is interesting about the wind, and plenty of students have difficulties with that. So here it is. Simple question, apparently. Whistle flying at flight level 180 on the northern hemisphere. An aircraft experiences right drift. What effect, if any, will have this on the aircraft's true altitude? And the correct answer is it decreases. Okay, so I will explain you that very simply. If we are in the northern hemisphere, okay, if we are on the northern hemisphere, so I put it here like that, northern hemisphere, we have two types, obviously, of pressure systems. We have high pressure systems like that, and low pressure system like that. Okay, and in the northern hemisphere, the wind is blowing clockwise around the high pressure system and anti-clockwise around a low pressure system. Okay, so taking that into account, when we go from a high to a low like that, the wind is obviously coming from our left side, and the aircraft will experience right drift. Okay, if it was the opposite, going from a low pressure system towards a high pressure system, the wind would come from the right of the aircraft, and the aircraft would experience left drift. Okay, so in this situation, the question says that the aircraft experiences a right drift. So necessarily, there is only one possibility, that is that we are going from a high pressure system towards a low pressure system. Then how can we link that to the fact that the true altitude is constantly decreasing? If we come back to the question says that we are flying at flight level 180. Okay, so at constant flight level, and flight level means that our altimeter is set on 1013 HPA. Okay, so let's say that the center of high pressure here has a pressure of 1025 HPA, for example, and the low pressure system 906, for example. Okay, if we represent the side view of the situation, we have the mean sea level, that is like that, and here where I have the high pressure system, I have a pressure at mean sea level of 1025, and here, where I have the low pressure system, I have a pressure of 906 HPA. Okay, now, because I am flying at constant flight level 180, I have to draw on this side view the profile of the pressure surface 1013. Okay, how can I do that? Here, at the point of high pressure, if the pressure is high, is at 1025 HPA, necessarily the 1013 is above mean sea level. Something like that, let's say, 1013. Okay, at the center of low pressure, because the pressure is at 906 HPA, necessarily the 1013 is below mean sea level. Okay, so now we can just draw a line that represents the pressure surface 1013, and we see that it's constantly decreasing. And then from this situation, the question says that, again, we fly at flight level 180. So at constant vertical distance from the 1013, okay, so here we are at flight level 180, and we keep this constant vertical distance until the point of low pressure. Okay, so we are still at flight level 180, but now the 1013 is below mean sea level. So this is why we can explain that, obviously, the true altitude here between the starting point and the arrival has decreased. Okay? So here it is, nothing more complicated than that. And you see that the explanation is as simple as we are going towards the center of low pressure. If we keep the flight level constant, necessarily, we have the true altitude that is decreasing. Okay? So it's something that we say a lot, that is good to remember, that whenever we fly in the northern hemisphere and we experience right drifts, it means that we are going towards the center of low pressure. So it means that our true altitude will have the tendency to decrease. Okay? So I let the explanation if you want to take a screenshot or anything. Here it is, and I hope that this explanation will help you in your ATPL study. I encourage you to contact me and to find me on coachapilot.com, and I wish you a very pleasant journey in your ATPL. Thank you for watching. Don't hesitate to like, to share, and to transfer to your colleagues. Thank you very much.